Alright, welcome to video number 6 of my series on making an action RPG in Unity. So this video picks up after we got the camera to follow the player, and we need to do a few kind of fixing things in this video. First, we can have this tearing effect. It might be hard to get it to occur, it depends on your camera moving, but as you move you might see the tile map, I guess, tearing at different points. Like you can see there's like a little line right here through all of this. It's extremely hard to see sometimes on the video. It's basically 1 pixel wide. And so we're going to fix that, and we're going to fix the kind of the stacking order. So let's begin. First, I do want to kind of point out about when I was doing the video last, and I was talking about switching the aspect ratio. The reason why free aspect was looking weird that one time was because that we calculate all of our ratio stuff during start. So if we switch the aspect ratio, it doesn't recalculate it, which is why it was having those weird clipping or going too far issues. So if you really wanted to, you could move some of these calculations over to fixed update. I don't really see the needs, and I don't suspect players will be changing that too often, but we could. So we could actually put that there and recalculate those every frame. I'm not a huge fan of doing that because I really don't think players will do it. But I'll leave that there in case you think that that could be something you're concerned about. And then I'm going to take out this debug log. I'm not going to need that. So it recompiles the scripts while the game's running. First off, let's fix this tearing issue. Now, this isn't going to fix it during the scene view when we're building it, if there happens to be any tearing. Nice. I think that's just because we recompiled it while I was playing. So let's go into the textures, tile sets, grassland. And we're going to make what's called a sprite atlas. So right-click grassland, and there should be a somewhere. There it is. That's under 2D sprite atlas. And a sprite atlas basically packs all of these tiles in. I'm going to call it Grassland Atlas. It packs all the tiles in, and it gives them a little bit of padding so that the tearing doesn't happen. And so with it selected, we can kind of see some options here. If we are concerned about any sort of filter mode affecting, we can always switch that. But to pack the tiles, we have to go to Objects for Packing and add something to this list. Now, when it does pop open this menu, and if you close this, it actually undoes it. And this is a real pain to scroll through because we have all of these. So what I recommend doing is just picking like the first, like the ActionRPG, the player 3, and then just dragging and dropping the sprite, the master sprite from here over to there. It's much easier than trying to pick it from the list. And I'm going to do that for Grassland 2 as well. I don't think I used water, so I don't really want to pack it, but I guess I'll pack it anyway. And then from there, you can click Pack Preview. It'll compile the Sprite Atlas. So it would have to have done this anyway if I hit play. And so you can kind of see that the cost is that it just has to build the Sprite Atlas. And if you change these sprites, it will have to rebuild the Atlas again. So that's something to keep it in mind, is that you really should only kind of build your Atlas when you're done with that tile set. That is a very interesting looking Atlas there. A lot of those water tiles. And when you do build that atlas, actually that will fix the tearing issue. So you can play it in, I don't have this vertical line tearing it anymore. So kind of an important thing to eventually take and play with, because that is going to fix a lot of problems, at least visually. All right, so that Sprite Atlas is built. Maybe we don't want to take that water out. And then repack it. Because I didn't use the water. No need to have that get shoved in there. Okay, so the Sprite Atlas is very clever with how it does some of these things. I think it actually will try to like overlap sprites and set the bounds to pull them in interesting ways. So you could look into that file and just be amused. Okay, so that is done. We fixed the tearing issues. So, but you'll notice you still might get it on this game preview, but the moment I hit play, that tearing will not be present. All right, next is to fix my stacking order with the doodads. So let's create another folder inside of scripts. I'm going to call this environment. And I'm going to make another script, C# script, and I'm going to call this doodad. Not plural because it actually refers to a singular doodad. Okay. I like how it opened that up and nothing changed. Then double click doodad to open the doodad script. And so in this script, what we're going to want to do is start, like, recalculate where it's going to figure its stacking position. Because right now, the tree, the ordering the layer is just set to 0. Everything's actually set to 0. But we want to dynamically calculate this order inside the layer so that we can base it off of, and what I'm thinking of basing it off of, is the bottom of my sprite. And I'm going to use that for determining where these things will stack. So let's set up these doodads. All right, need some variables. Let's go do our public-facing ones first. So first up is a debugging one that I call debug draw gizmos. I'm going to use this to show, if you turn this on, it'll show where the line for calculating its layer is. Then we'll have a float called offset y. And this is going to be used for like adjusting things such as the reads, where the bottom of the sprite may not be where we want to actually have the stacking, the layering occur. And there's actually, like, these two things are going to go hand in hand, and I'll demonstrate that. Kind of building something in for future. Do I want this doodad to block projectiles? And so those are going to be the public variables. I don't feel like draw debug gizmos really needs a tooltip. Let's call these internal variables again. Internal variables. So we've got, I need my sprite collider for sure. A sprite renderer. I think that's all I really need. The start does need to link the sprite renderer to the component. So So we have to use get component. Hopefully I can spell it correctly. And so we link up our sprite renderer to that, and then we just do our calculation here. So and so we're going to calculate the layer order. The main thing to know about this is if you do go and look up the actual layer order variable, it has to be between these two values. So my upper limit is 32,000, my lower limit is negative 32,000. So when we calculate this, we just have to keep that in mind. So we're going to access my lowercase s sprite renderer, and we're going to access the variable called sorting order. And we're going to set that equal to, and this is where we have to kind of decide my biggest math. If I do something like 20,000, and then I'll do minus, and I have to cast this to an int, sprite renderer, the bounds min y plus that offset that we created, times some number to take it from being a float, because keep in mind that we have decimal-based precision, but layer order can only be whole numbers. So let's think if we do like times 100. If we do times 100, what that means is every one tile is 100 units, which will cap us at a size of 200 tiles by 200 tiles as a maximum size for our thing. If that seems fine, I mean, we could even bump this up to 300, and our max would be 300 tiles by 300 tiles. So that's just something we kind of have to think about, what would make the most sense. I don't honestly think I'll ever build anything that has 300 by 300 tiles. Like, even this was only 30 tiles. I need something 10 times as large to be bigger. But so just something to keep in mind. And obviously you could lower this number. You'd have less fidelity in terms of calculating it, but like even if you drop this to, like, if you drop it to 10, that will look bad. I have tested it with 10, but that'll bump you up to 3,000 by 3,000 tiles. Honestly, I don't even think anybody's going to hit this, and if you did, just drop it to 50. It doesn't have to be a scalar of 10. And if you did it by 50, that brings you up to 600 by 600 tiles. And then this still has very high fidelity in terms of stacking order. So that is what I recommend. But now for just to kind of throw an extra piece on here, we're going to have private void on draw gizmos. And we're going to have if debug draw gizmos. So if that is enabled, we're going to draw the line that we're going to use to calculate the layering order. So basically we're going to take this calculation and turn that into a line. We do have to get this component again right here, because this code can actually execute before the start does. So we do have to grab that for the purposes of being inside the editor. You know what? Let's just do the y value here. We can just take this before we multiplied it by 100. So the y value is going to be the lower y plus the offset. So we can actually kind of see this. The bottom left is going to be a new vector 2 with sprite renderer bounds min x, comma, this thing I called y value. And then we'll have another one. Needs to be lowercase s, sprite renderer. Call this bottom right. We're going to copy the same exact thing, but instead we'll use the max x value, because that's going to be the rightmost part. And now to draw the line. Gizmos.color equals color. I'll do cyan. I have plans for green, yellow, and red as part of the enemies. And so if this is enabled, it will draw a cyan colored line where it is calculating these overlaps at. So hit save, and now we've got this set up. We do want to also take this command and put this inside of our player as well. So I am going to copy and paste part of this. And I'm going to go over to player, and inside of update, I will put it right here. I don't think the player needs an offset, so I'm going to take that offset out. We could add it if we wanted to, but right now I know that it's just going to use the lower edge of the player sprite for these calculations. If we find that that doesn't work for some reason, we may have to go back through and give the player an offset as well, just like we did for the doodad. So it's going to compile. Now, considering that my doodads are all prefabs, I think it's going to be easier if I just go to the prefab for it and attach the doodad script like that. And now this barrel should have it. So if I turn on draw debug gizmos, we can see that that's actually where the barrel will be using the line to determine the stacking order. So we can turn that off. We don't want to see it. And you know what? Let's jump over to the player. And we could do the same thing for the player. So I guess let's bring in this. So go to doodads. I'm going to take and copy and paste these. The draw debug gizmo and the offset y. And I'll put it inside of player. And we'll put it here. Hit save. And we'll give the player, we'll copy and paste this on draw gizmos method. And so that way the player can do the same thing. Now it does mean the player is, this player script is getting larger. It doesn't matter where you paste it, I just pasted it anywhere. And you can always shrink these things if they are massive. So the player now has that feature as well. So if we wanted to see that on the player, we could also go and turn on the draw gizmo. And we can turn it on for the barrel. And I'm going to turn on gizmos in the game mode. So if you click on gizmos here, you should get the lines appearing under things. Then we can hit play. And you know, when we're under here, we can see that we're appearing behind the barrel. And then once my line is below the line of the barrel, I appear in front of it. So looking at it, I may want to move the barrels up a little bit because I think in this perspective I should be in front of the barrel. And so you can use these to kind of help troubleshoot and plan for when, like in this case, I think I'm in front of the barrel. So I kind of feel like the barrels needs to go up a little bit. And why I've enabled these gizmos is because it will let you, as you adjust this offset Y, you can even click and drag it. Oops, I went way too far. It needs to be like a very small decimal, like 0.2. You can see if I made that negative, it moves it down there. If I did positive 0.2, it moves that line for calculations that if I'm above this line, I'm behind it. If I'm in front of this line, I'm in front of it. And we can see how that looks. Oops. Zoomed in on game. And so like when I'm standing here, I'm in front, but when I'm up here, I'm behind. And I think that looks kind of natural. As natural as it's going to look. And so I just need to do this for all the objects. So all of these need to have the doodad scripts. So I'm going to drag it onto the tree stump. I'm going to drag it onto the tree. I'm going to drag it on the reed and the bush. So whenever I'm happy with the barrel, I can turn this off so I don't see it. And then for the tree, for instance, let's take a look at where its gizmo is. And I do think the tree should block projectiles, so I turn that on. And so comparing the player to the tree, you know, this looks correct. But whenever I go here, you know, I'm like appearing slightly behind that root there, which doesn't look accurate. So like this tree's line needs to be up a little bit higher, maybe about like right here. And so again, you can kind of see the utility of this. And you can see that this tooltip makes sense. Positive numbers makes this object more likely to be behind things. It's kind of hard to describe that. So 0.7, let's see how that looks. So I'm still behind the tree, and then at this point, I'm in front. That's going to be hard to fix. That honestly, that shadow needs to be on a separate layer, but I can't really do much about that. But aside from that shadow, I think it looks fine. I mean, I could try to fix it a little bit by making the collider bigger. Whoa, what's going on? It's like when I pulled this up, like maybe it could be worth considering making this collider slightly larger so that the player can't really stand in that shadow. And that might help fix some of that illusion. Where the player was appearing behind it. And so it's a lot more minimized now, but overall looks pretty good. Then we've got the bush. The player's appearing correctly behind the bush. The reeds are kind of tricky, but you know, you can play with the offset to get the reeds to look how you want. Like in this case, I guess the player is behind it. But so we've got all of these different objects. And this is what I was originally saying, how because there's 3 reeds in this picture, realistically this should have been 3 separate doodads, because this one needs to have a different point for its offset than the other ones do. And so that leads us to this little thing here that we need to fix. Tree stump? How's tree stump look? Tree stump needs fixed. I think the tree stump has the same issue as the tree, in that it needs it up a little bit higher. Probably around like that. Okay, so tree stump looks good. I'm gonna turn off these draw things. I'm gonna turn it off on the player as well. Alright, and so really the last thing left to fix here is just this overhang from that from that cliff. And we're going to take a look at the player's position to get that set up right. I could probably turn off gizmos, but... So all this looks good. We've got appearing correctly in front of and behind bushes. So, but this one is sticking out problematically. So what we really want to do is try to figure what height this needs to be so that the player appears correctly on it. And you can even see I need some extra stuff like all around it. So let's pause and go look at the player and take a look at its layer order. So the player is currently 29, 30, 310. So let's just write that down. 29, 310. And let's play with, well, I guess let's move this to a separate layer. It needs its own thing other than treetops. So I'm going to exit out of that. We're going to make, and this is kind of a one-off thing, but I'm going to create a new tile map. And I'm going to call this cave top. And so let's pull up our tile map editor. Jeez, where is that tile palette? And so I do want to erase this thing off of treetops, because I think, if I recall, I painted that on treetops. These can still stay on top of, those are blocking high right now. Cave top, let's paint this. Let's paint a grass tile. And then let's paint the other parts to the roof here. So I have kind of a tile stacked on top of another tile. We're using the original set. We're using the one on blocking high to, control collisions. But this one that I've painted on cave top, we're going to kind of set its layer order based on what we saw from the player. So layer order, the higher your number, the more likely you are to appear on top of things. So if the player was this value here, let's start with setting something similar. Let's see. What's up with treetops? Oops. I've lost my notepad file. Notepad says 29, 31. Okay. So let's go walk over there as the player and tweak that number until it looks right. You can see that that has fixed it appearing in front of the tree. So we need it to be blocking the player even when the player is standing here. So let's hit pause. And the player is currently at 29,441. So let's see if we set cave top to 29,440. And then we can resume play. Now, ideally, we shouldn't see the top of this hair here. We could add these tree stumps to it to try to create a tile that doesn't look weird. But as far as I can tell right now, the player does look fine. So when we exit play mode, it is going to lose this. So I'm going to copy this number back over to Notepad, and that's what we want to set it to. So this layer cave top needs to be set to that number that we experimented with, and that looked actually pretty good. Let's go to cave top and paint one more time. So kind of the frustrating thing is if I paint like this tree edge right there, if I paint it, it's only going to paint that. So I don't know. I just have to make sure the player gets warped to the cave before we can see the top of his hair sticking up through that tile. which I think will happen, because when we walk into this, we'll zone immediately. And so while it does look kind of funky here, that's because this tree's layer order isn't being set until runtime. I mean, we could update its layer. We can hit pause and go see what it's being set to right now. So it's being set to that. So if that is bothering you, you can just change this right now. Like I said, it's being set during runtime, so we could change it for that tree specifically, just so that when we're building the level, it doesn't sit there annoying us. And so that fixes pretty much all the doodad related things. Any extra doodads we add, we will need to attach that script to and set it up. But it does kind of give us the ability to walk in front of things and walk behind things. And so now we've got a little bit more variety to how my world feels. So remember to turn off gizmos if that's bothersome. So what we're going to do next is take a look at setting up another scene so that we can begin scene transitions. So the next video is going to focus on actually making 3 new scenes. We're going to make a scene for the cave, we're going to make a scene for going off to the east, and we're going to make a scene for going off to the south. And I'm actually doing all of those because it will let me test each exit direction. And so I guess join me for that. We'll make the player prefab in that video, and we will make some scene transitions. So thank you for watching.